Thank you very much indeed. Chris Swainston, now of this parish, as it were, and chair of EH4 Soil Quality for the moment, member of the AGS as well, who I gave essentially this presentation to, and from which has stemmed various works, which I'm going to go into at the end, to show how sustainability has taken a major lead. I must apologise for my voice. It was basically non-existent yesterday, so this is at least some improvement. So if we can actually get this to work, I'll go through a little bit of UK site investigation history, using a very nice presentation produced by one of Professor Paul Nathaniel's students, to show some of the history of how contaminated land and site investigations developed in this period. Nice to note that there are a couple of things in there, 2000 to 2009. In 2007, it's noted that there was an incident, 2002, St Leonard's Court, which was the first ever Part 2A determination over in Sandridge, which I actually did the monitoring for, collecting the information and the data on behalf of the Environment Agency. Various other elements and bits and pieces in there, of course, Corby, which brought everything to mind in relation to development and how contaminated land was an important aspect of it, from the health and safety implications that it could give rise to in the development of your site. But generally, it can be broken down into the 1970s, it being a nuisance issue more than anything. That was when the landfill guidance essentially first came out, 1974. Previous to that, it had all been done in a fairly ad hoc way, to be honest, by the local authorities. And it was put on a sound footing for them to determine that actually doing all of these things and burying this waste all over the place wasn't necessarily a brilliant idea, and need to have some form of regulation, registration and oversight over what was being done. In the 1980s, it became more a waste brownfield land or a political issue. It was seen that what are we going to do with this brownfield land that's potentially contaminated? What are we going to do about waste? It's filling up all these landfills everywhere. We're not doing an awful lot about recycling wastes and stuff. So it was all the start of that really in the 1980s that brought it to prominence, culminating the 1990s, of course, with the Environment Act, the creation of the Environment Agency, Scottish Environmental Protection Agency, and water became part of the mix on that basis, and it became a financial issue. It became another hurdle to overcome, another reason for why you'd want to do investigation. And it was really, I suppose, the start of the major revolution in contaminated land that subsequently went on to the 2000s, to the creation of the Contaminated Land Exposure Assessment Model. Before, it had been quite literally on the back of a fag packet, what was in theory going to be acceptable levels of contaminants. I could take you to the actual public house just to the east of the current British Standards Institute, where literally the 5 people concerned did write it down on the back of a fag packet and a beer mat for those original CLR numbers. It became then a waste issue again. Sustainability was included, a way forward, and it became more of a perhaps moral issue. We now had a financial and legislative framework in which to view things, and it was a question of how we take this forward into the real way of working things. And that's pretty much the way it's been on and off for the last 20 years. And I've been very proud to be a part of most of it as it's been going through that. And the regulators have been established to police and provide advice on select parts of it, which has been of variable use. And planning was established as the mechanism to capture contaminated land sites. So looking at site investigation and sustainability, site investigation as per BS 10175 is driven by unknowns. and it's concentrating on the contaminants of concern will improve sustainability. So what do you already know? What can you discover during the desk study process? Has anybody done some investigation there already that has numbers that you can look at and go through? And you then determine what you don't know, what you still need to know, and determine what is the best way to find that information. And that information may be, as per the British standard, to either undertake further formal study, see if there is other information out there that you can get from the BGS or from the local authority or somebody like that, which can give you advice on what else may be known or unknown, or what other aspects can come into play. It may be, for example, that information has been gathered on this site before, but you talk to the local authority and they say, oh, yes, actually, we're a bit concerned about XYZ being in the area. So, for example, if you were looking at a site investigation in Stoke, you may learn that there is a lot of potteries and glass material around in the Stoke area that has been used as fill over the years because it breaks down into nice granular material, especially useful if you're in allotments to make sure that your clay actually has some vague amount of water being able to pass through it, improving the drainage of it. And on that basis, there is a potential for you to find radioactive glazes and glassware in the general area. And you would not necessarily know that or be aware of that until you'd actually done the original investigation and had highlighted this potential unknown that you now need to have a look at separately. So it can come in a multi-phased approach. And when you reach the phase at which you're happy, you have assessed all of the appropriate risks to the level that is required, then you stop. Or at least that's the theory. The problem is in reality that one of the things that has happened over time is that people have latched on to the idea of unknowns and they say, well, okay, you're concentrating on the contaminants of concern, which you have said are lead on this site, but we'd actually like you to test for a load of other parameters as well during your investigation, because there are these unknowns and we'd like some quantification of what those unknowns could be. So what we've actually done, as opposed to what was originally envisaged, was that you burrow down to only those contaminants of concern, only those things that you really need to know, meant that it was sustainable by default, because you were avoiding doing the whole mass of other stuff you might have to do. But as I say, in reality, that's not necessarily how it's actually panned out. But you've got to consider other aspects when you're going on site investigation, the accessibility for it. Is it going to be easier to go onto this site that is covered in a mass of materials, possibly including knotweed, things like that? Or do you have to take these things into account? And actually the most sustainable way to achieve accessibility is possibly to choose a different method than what you were originally going to propose to do. Competence, certainly, absolutely. The competence of the people who are doing this should be absolutely proven. It should be proven because BS 10175 says that investigations, and indeed the reading of itself and the utilization of itself as a standard, should require competence. Competent people should have an eye onto sustainability. Reliance. How much can you rely on the information you've already been given? If you have good reliance on it, then you probably need to do less actual stuff just to fill in the gaps of the information that you've got, if you can be properly reliant on it. The scientific certainty of that information. Is it good information? Is it good data? If it's lab data, is it MCERTS accredited? Did it generate any non-conformances? Are you scientifically certain that the monitoring or anything else you're going to do on site is actually valid, is going to produce you a certain result at the end of the day? And will that be repeatable? Because if it is repeatable and you can prove that through QA/QC, then you're actually going to have a better chance of sustainability if you can take 20 samples and a couple of Q&As to make 22, rather than doing 40, as is perhaps suggested on the grid, because you know that the material is likely to be very, very similar across it, then you can prove that repeatability. You only need to do those 22 samples, not necessarily the 40 that the guidance would tell you. And that's where competence and reliance comes in again. That all then hopefully leads to actually producing a site investigation that ultimately will be sustainable because it bears in mind all of these factors on all of these considerations. So coming to standards, why do we use or create them? Because they promote good practice. They are what you should ideally be doing or stating when you don't, when you've got a better idea, or you've got something that's more justifiable than what's in the standard, why you're not using the standard. So it encourages innovation, passes on knowledge. Most of the information that we have as contaminated land experts is what we've picked up, to be honest. And it is little things like Stoke, consider thoughts about radioactivity in glazes and glasses, and various other things around the UK as well. So if you went to Walsall, knowing the fact that half of Walsall has been undermined for previous limestone mining during the Industrial Revolution is very, very useful to know, certainly from a geotechnical point of view. So most of the knowledge, it can be passed on, but a fair amount of it is usually quite site specific, which is as it should be and why we should be investigating. It also levels the playing field. It means everybody's working to the same level, working to the same standard, and this provides certainty and surety to clients and regulators, knowing that you are in compliance with BS 10175, the British standard, or BS 5930 for your gas works and so on and so forth, then provide certainty to the clients and the regulators that you know what you're doing and that you're following the appropriate guidance and standards. It therefore provides confidence in your findings. Yes, we have confidence in our findings because we've done it in the way that the standard suggests. It promotes professionalism. In compliance with the standard, it can often be the case that it won't necessarily be in compliance with what your client wants, but it promotes professionalism by encouraging you to state that actually, yes, it does need to be done to that standard. The regulator will expect that, therefore that is what we will be doing it for you, because at least 95% of what we do is ultimately for a regulator to look over and agree. It avoids reinventing the wheel. There are lots of different ways you can undertake a site investigation, and the various pros and cons are noted in the standards where there's potential options, and it's certainly worth reading those and understanding them to get an idea of when certain things may be appropriate and when they wouldn't be. And these notes are looked at very carefully. They're provided by people who are absolutely at the top of their game and the industry, and so you're getting the best advice that we can give you. So it's produced and accredited also by national or international bodies who are basically backing the fact that it's experts who are producing it, and they're producing it in a reasonable, sensible way as experts in their field. And it is subject to scrutiny by fellow experts, interested parties, and members of the public as well through the various processes involved in the production of them. So then we come to the point of whether there's guidance versus legislation. What is the difference between the two? Most standards in our field are certainly, in fact, guidance documents. Where you have a standard that is legislatively driven or something like that, is something like a plug, where it is you must do something, not you should do something, or you can do something, or you may do something. You must do something. All plugs to comply with the appropriate standard in Britain have to be wired up in exactly the same way with exactly the same safeguards in it in order to get the British standard mark on them. They must do what is said in that standard. However, our standards, BS 10175, 8485, 18400, you should, not you must. We are recommending what should be done. But if you can justify why you've not done something, then that's perfectly acceptable. it shows that at least you've looked at the standard and you've come up with a good rationale as to why you might want to do something slightly different in this case, or not do what the standard actually recommends. What other bodies do is also produce guidance, but is it of equal relevance? Well, standards can also be suggestions or ways of doing things, i.e. guides to good practice, and what they will also be, aside from being guidance, they can point you in the right direction to other guidance that is relevant to what you're doing. And certainly the references at the end form the key part of pretty much everybody in this industry's sort of guidebook or wall as to what standards apply to which parts of site investigation. And so it's a very good resource, if only for that reason at all. And one of the reasons why we're updating it at the moment is some of the guidance references in the current version, plus A2 17, are now superseded. So examples of good guidance that you can potentially use are the AGS data format, the AGS guidance on asbestos site works, which was updated last year. There's also various bits on site investigation, made ground descriptions and various things like that, which are usually referenced in standards, so you don't have to be hunting and searching for them in order to find them and use them. And the nice thing about particularly the AGS ones is that they're generally free to download. So in terms of sustainability and standards, since about 2011, we've been required as standards producers to promote sustainability as a goal in any standard we produce. We should ideally be promoting and providing evidence of which are the most sustainable methods and ways to undertake whatever the task is that the standard applies to. Prime example of that would be BS 10176, where you have a hierarchy for the determination of VOCs and SVOCs. At the top level, if it's vitally important, you know exactly what each VOC is in your soil. You need to preserve it in order to get it to the GCMS that you're going to actually put it through and all the rest of it. You will need, in order to preserve that material, to shove it in a solvent. That is expensive. It's not necessarily all that health and safety wonderful, but you only have to do that if it's actually justified, that you need that information in excruciatingly fine detail. If you just need to know whether something's there or not, you don't necessarily need to use the solvents. So other options are available. Yes, you will have less certainty in the results, but it may be the case that you don't actually need that level of certainty. So sustainability is built in because you would choose the appropriate method to get the results that you actually need by using the most efficient and sustainably cost-effective way of actually getting that. So following standards advice should, for any standard after 2011, be the most sustainable way of achieving the goals that the standard sets. Compliance with legislation is usually automatic with standards, so there's little duplication of effort. So follow the standard. You're usually doing what the regulator expects you to do, because they will expect you to follow the standard. Therefore, you're not duplicating effort, which is, by definition of itself, sustainable. Also, you can have standards that are specifically related to sustainability. And I would point out 18504 by Paul Nathaniel on sustainable remediation, which has the slightly dubious distinction of being the only sustainability standard that doesn't have a political or economic agenda. It basically sets out the scientific basis for how to achieve sustainable remediation, how to calculate it, and how to therefore determine what you actually want to do. And unlike a lot of standards on requirements on sustainability, which tend to be written by governments or their appointed persons, they all come with baggage attached, political baggage usually, either from, yes, environment takes precedence through requirements to satisfy people about global warming, or it could be sustainability on the basis of social need. It could be sustainability on the basis of economics. It could be sustainability on the basis of reuse, economic revitalization of land resources. there is usually baggage that comes with sustainability, and you should be aware of that before you use anything. And therefore, I would certainly, in terms of remediation, recommend the sustainable remediation ISO standard, because it comes with absolutely no political baggage. You put in and bias it in whatever way you see fit. So it can be present as a specific goal as well to achieving many standards, along with carbon reduction, cost effectiveness, and so on. So you've got 9001 in order to streamline your management services and systems and make sure that they're working and giving best value to you in return for what you do. And 14001, which of course is itself an environmental standard. One thing to be aware of that, it doesn't give you a benchmark to say, yes, you're an environmentally nice company if you achieve this standard. What it says is you will undertake to improve your environmental credentials, you will improve your sustainability, both of which should by definition, by reducing carbon use and footprint and so on, also lead to a more sustainable, cost-effective, economic, beneficial business. So it has quite a lot of uses, of which sustainability is only one. Sustainability doesn't always mean cheaper, but in the long term, it always will. And it should ensure a continuous and give you a map as to how you're going to achieve it. So they're very, very good standards in order to provide guidance as to where to go. And they give you a benchmark to measure that against, and that you can be audited against. And that is very, very useful when going out and looking for work, particularly for tendering, for site investigation and things like that on the environmental side, when you can just automatically tick the, yes, I've got the 9001, yes, I've got the 14001, yes, I've got the 18001 or 45001 for health and safety, which basically is a requirement of any tender anybody's ever going to send you. So it is more sustainable if you got it. And when I was working for Geotechnics previously, we reckon it probably saved about 3 times as much as it cost to run the system in terms of being able to tick those boxes in each tender that came in, rather than actually just having to write down everything that tender required us to say, because we didn't have those particular ticky boxes. One of the main problems you come across is that clients often don't value contaminated land risk assessment, investigation and standards, but view them unfortunately as necessary evils driven by the legislation and planning. But if you use it to your advantage and know how to do that, then it can be so much more, because you can make it sustainable, you can make it cost effective, you can make it so that it's going to get through the legislation from planning through first time, because you've been in compliance with it. And all of that coming together means that it should be valued, and it can be valued, and it can be made to work for you. Sustainability itself can be designated as a goal during any part of the investigation, design and development process. It can be fed into any part of CDM very, very easily. And ideally, to get the best out of it, it should be organised, considered from start to finish as part of the whole process, because that's the way CDM views it when you get involved in that. And it is now a specific goal which you can achieve through appropriate use of that. So sustainable goals are not always the most cost effective in the short term, but always in the longer term they will be. So a prime example of that is that with the ideas of zero carbon that we're going to in housing and things like that, then one of the things you can obviously do is incorporate a double skin wall, stick in extra insulation, make sure the loft is insulated before you sell it, put it in at the time that's easiest, i.e. just after the roof's gone on, and you've got the best access without messing other things up. So in the short term, yes, that will lead to you having to A, think about it, and B, might lead to a slightly more expensive building being created, but that will pay for itself over time to the resident, if not necessarily to the person who's building and developing it. So it will always, always pay for itself in the longer term. The only thing to discover or to try and work out is how much over what period of time it will actually save you. And there are a lot of specialist companies out now there who provide exactly that service for you. So you don't even have to think about it yourself. Standards should suggest and reflect the most sustainable way of undertaking a specific task, as I've said, and that should be the most sustainable way. But we are always willing to accept that there may be other options that actually in a specific circumstance are more sustainable, but it's down to the practitioner to do that and determine that that is the case. But compliance with standards on the basis of what I've said should be sustainable by default and is meant to be. So what do we mean by best practice? Well, working standards and best practice guidance should in theory mean, with various iterations more so than others, some consideration is given to sustainability. But as always, there needs to be consideration of the equilibrium between sustainability, cost, quality, practicality, and suitability. The cost specifically in relation to how much this development is going to cost, how much this investigation is going to cost, how much everything is going to cost. The quality of that is going to determine whether you're actually getting your value for money, whether your cost is actually worth it or not. And that is a key factor which is in Prince 2, which doesn't necessarily seem to have necessarily made its way to a large amount of our clients who want to tender. However, quality pays for itself in a sustainable fashion. Practicality, working out the best, most reasonable way to do something, can include sustainability as a goal and should include sustainability as a goal, because that will have a direct impact on cost and the quality of the data that you're going to get out. If you can get in with precisely the correct method for taking a class 1 sample, your information geotechnically will be absolutely spot on, plus or minus 5% in the calculations, meaning you can potentially do a much, much better foundation solution with a lot less slack in it and use a lot less materials, being infinitely more cost effective and sustainable in what you're doing. If it's not practical to get that class 1 sample for whatever reason, then you might want to be thinking about how can I make it such that it is practical to get that sample? Or actually, doesn't it matter? I can get a class 2 sample instead. That will be fine. I apply a plus or minus 30% instead of 10% for a class 2 sample. Therefore, actually, that's not too bad a thing to do. We can practically get that class 2 sample, so that's what we'll do. It's cheaper, it's easier to get on site, it's easier to do all the rest of the other things you need to do, so that's the way we'll do it. Suitability, fitness for purpose. Is what we're doing actually suitable in terms of achieving sustainability, reducing cost, improving quality, being the most practical way to do it? Is what we're doing suitable? And that sort of double or second check on yourself is something that unfortunately a lot of people seem to miss out as a step, but it is absolutely essential. And the suitability should at all times be, are we achieving the goal we want to achieve, and or are we achieving compliance with the standard that is telling us which is the best, or standards that are telling us the best way to do what we're actually attempting to do. And it's that suitability element, not necessarily the quality. Quality, compliance with standards, yes, an obvious thing, but it's actually in that round, the suitability as to where standards actually have the greatest impact in what is being done. And it's probably our failure to point that out to people that explains why clients do have this sort of laissez-faire attitude to standards and standard compliance, because they don't realize how useful it can actually be as a second check on your suitability criteria for determining best practice. So in terms of best practice, you've got to consider the context, you've got to consider the data quality requirements you need, the speed with which you need the information back, the cost that it's actually going to be, the logistics, the practicalities, the location, the matrix of the material that you're actually going to do. Is it soils you're after? Is it gases? Is it waters? Whatever. What levels of accreditation do you need? Do you need to ensure no non-conformances because you're giving it to the Environment Agency or somebody who can quite legitimately turn around and say, you have non-conformances in this data, we therefore don't accept it. And that is something that will bite you once and never again, because you will never do it again, because it will cost you so much to replicate that data that you will learn from your experience. One of the other things, of course, is the critical levels of interest. How much interest is there in what you're doing? Is it purely legislative? Is it purely planning compliance? Or is it just local people or whatever? And all considerations for delivering a fit for purpose and a considered solution are basically summarized in that list above. And they will generally be something a lab will be happy to discuss at project's inception, because they'll be able to tell you what is the best method to choose, what is the best way to get you the data in the way you need it, maybe AGS format, maybe Excel format, maybe a has waste online format or whatever, and what the quality of that data is going to be. That will usually be backed up by their ISO 9001 accreditation and or 14001 accreditation and their certification details as well, ensuring their data quality. The speed at which it can be undertaken. Speak to a lab and you can talk to them about possibly 1 day, 3 day, 5 day, 10-day turnarounds, depending upon how urgent it is that you get that data back. They can also discuss cost with you, because that will vary with speed and what you're doing. So that's an element that is particularly important. And in terms of choosing a lab, usually the key thing at the end of the day. And therefore it's a problem sometimes where people don't actually speak to the laboratory and say, yeah, I want to do this, I want to do that, I want to do the other. What's the best way of getting this data? What is the best testing to undertake to get me the data I need? So logistics, practicality and location, getting the samples to a location and from a location. Water samples, never ever take water samples on a Thursday or Friday. You will guarantee to generate a non-conformance unless you can get them into the lab and booked in within 24 hours. Basically, half your water parameters will be non-conforming, and they won't do them on a Saturday morning. They won't do them on a Sunday because they don't work those days. They're not classified as laboratory working days. So a word of advice from one who's learned the hard way: never ever take water samples on a Thursday or Friday. Always take them at the beginning of the week if you can. In terms of the matrix, as I say, certain laboratories will have certain specialities. There are certain people, if I was doing specifically work related to hydrocarbons, that I'd use in preference to others, even though they're slightly more expensive, because I know they have the expertise that if I need an interpretation, they'll be able to tell me. They'll be able to look at the GCMS traces and say, yeah, there you are. You've got what looks like a weathered petroleum derivative. It seems to have been weathering for about 30, 40 years, we'd estimate, or something like that, which is all very, very useful information when you're trying to track down specifically who offsite is contaminating the site that you're wanting to develop. So in terms of part 2A, it becomes vitally important to have that information. If you've used a laboratory knowing that you're going to need that level of detail that can't provide you with that, then you've done yourself a disservice and may have to replicate what you've done, which is obviously not sustainable. So in terms of the accreditation, that should all come as standard, UCAS, absolutely. And certain of the standards are, by stating compliance with them, de facto standards in their own right. So that's 9001, 14001 and 35756, if I remember correctly, which is the UK laboratory standards. Critical levels of interest are absolutely key. There are certainly some times where you can get the lab involved and or interested in the project and gain benefit thereby. Often that will not happen, but sometimes it can. So it's worth asking them, because you may be able to get a better deal from one lab because they're actually interested in that particular parameter, or perhaps developing a relationship with a certain client of yours by becoming the people who supply them with good, decent information. So it's a bit of a quid pro quo in terms of best practice. So in conclusions, investigations, models assessment, data management all have very good standards which apply to them. including one for essentially what is AGS data as well, which the AGS group put forward to become a European standard, and now is, for the transfer of electronic information between data systems. They are now designed to promote or aid sustainability, be that one of your project goals or a requirement of a project or works you're undertaking as a result of required compliance with a standard. So sustainability can and arguably should be built into all parts of the development process: site investigation, CDM, all the way through the entire design process, the building process, all the rest of that. And there are standards for pretty much every single part of that that you can use to show how you have done that, how you have considered those elements, how you have complied with the sustainability requirement that the actual client at the end of the day has put as a project goal. Likewise, also the appraisal system in remediation strategies as well. Sustainability can and indeed should be emplaced within that process. It's not necessarily specifically noted in the LCRM Environment Agency guidance available on their website, but it's certainly there as one of the examples. Most clients we're finding are choosing cost effectiveness, but cost effectiveness is a part of sustainability. So we're getting there. We're getting there in most cases. So various compliances with standards should always be more sustainable by default, because you're not reinventing the wheel. They're designed to do that. And it should also tick the boxes of regulators, so you're not repeating yourself, because regulators will be expecting you to do things to the standards they've named or which are appropriate to the task in hand. So comments and thoughts on that. Well, waste and asbestos, the current elephants in the room, really. BS 10175 should be your first port of call for any information regarding site investigation and how it's undertaken in the UK, and it should form a part of a considered management strategy for the entire project. Conceptual site models, CSMs, are absolutely the key to determining what is most sustainable, knowing what information you've got, what information you haven't got, what your conceptual model is telling you is known, what it's telling you remains unknown and needs to be investigated, are absolutely the key to effective use of any of the other standards that apply to this. Over-conservative risk assessment is unsustainable. Knowing what your CSM is, having faith in it, having faith in the way it's been created, the data that backs it up, the standards that have been used to create it, will make it sustainable. If you're erring too much on the side of caution, it's unsustainable, because you shouldn't be doing that, because you should have faith in everything that has been provided to come to that conclusion. So UK processes can be sustainable if set as a goal and the regulator is happy, because, as I say, the big, not elephant in the room, but the big problem that we've discovered over the last 20 years of using CLEAR under planning, and CLR as was, LCRM as now, is that everybody's picked up on the unknowns without necessarily understanding the underlying philosophy of, actually, no, it's meant to concentrate your mind on those contaminants, individual contaminants, that are actually concerning. The problem is, what we've actually come across is there are still other unknowns, which therefore actually like you to do more than you need to, which is unsustainable and defeats the object of the exercise. But that's the way it's gone in practice. And yes, this is a personal gripe of mine, because I was originally taught this by Paul Nathaniel, Judith, and the rest of them who wrote the CLR and CLEAR guidance in the first place. And they were very specific about exactly why it was scheduled and set up this way. But that seems to have been lost in translation over the last 20 years of applying it. People seem to have forgotten the underlying philosophy. So sustainability, not always less costly, but always more effective in the longer term. I've yet to see an example of where putting a carbon reduction sustainability goal into a project has ever led to it actually being more expensive at the end of the day. yet to find one ever. So worth doing. Data gather, retention and transfer will also help over time. As more of these unknowns are dealt with, as more of this information is kept through BIMs and other systems using AGS data format collection systems or BGS or whatever, all of this data means that we will eventually not have to do as much actual investigation. And it's actual investigation physically that is perhaps the most unsustainable part of our business, simply on the basis that you've got to get people there, you've got to pay them, you've got to take equipment there, you've got to put samples in for analysis and do testing and all of this, that and the other, which is expensive, which is resource utilization heavy. And the more data we've got, the more we're able to say at stage one, when we're doing the desk study, somebody did an investigation before the last building went in, and they discovered this, that, and the other. They remediated this. Therefore, on this basis, because we trust the information and the data that they got X number of years ago, we think it's very, very likely that you don't need to do any more investigation, and you might find something unusual, unexpected. So have a discovery strategy in place. But phase one, you end it. You don't take the planning process any further beyond that. And so therefore, our industry is going to become more sustainable over time, if only because of the data gathering, retention and transfer potential that we have for future development. So that brings me on to the AGS and the works in process that we've got at the moment, and which I'd like to just make you aware of. This has been led by the Institute of Civil Engineers, developers, clients, and the AGS as a whole, and society, to develop best practice in sustainability, including climate change and resource use, and reducing costs. So the forwardness on this is led ultimately by the AGS board and the Contaminated Land Working Group within it, and the Sustainability Subgroup, all of which I'm members of, and now becoming part of the Environmental Industries Commission's thoughts on what they want to be doing next year as well. But it's the ICE developers, clients and society. We have the Atkins of this world currently doing work for the Environment Agency on improving sustainability in relation to climate change, because they're rewriting and reassessing all of the flood maps in the light of new potential climate changes. So it will answer the question, are our 1 in 100 year flood events that we have to account for actually now, with climate change producing more extreme events, actually going to turn them into 1 in 30 year events or 1 in 10 year events? And being able to actually do that is going to ultimately, by having greater reliance on the data, mean that when we're doing flood risk assessments, we will be able to much more effectively assess the potential risks, as will the regulators, which will be more sustainable, much more risk averse than what we're doing at the moment. So that in itself will be a sustainable action by default, and benefit all of us within the industry and society at large. So what we're doing at the moment is devising procedures, gathering evidence, demonstrating best practice in the industry to clean up and tidy up the industry that we've already got and the practices that we're already following. So when is it more effective to take a window sampler out? When is it more effective to take out somebody to dig a hole in the ground? Well, if you're only going to 60 centimetres, looking at the top garden area or potential garden area of a site, then yeah, what's the point in taking a window sampler out, or the extra weight you're carrying, actually putting fuel into the window sampling system itself, and so on and so forth. And how many samples do you need to take? Do you need to be taking 100 samples when only about 10 of them are going to be potentially tested? Or should you perhaps send an engineer who's a bit more expensive to send out onto site, but who can say take 10 samples, knowing that they're all going to be tested, knowing that they're all going to be reasonable, knowing that they're all going to be used, thus cutting down on the extra stuff that you would normally, if it was a technician doing it or a logging engineer, take as standard. So on that basis, we're looking at these procedures, everything that we do, looking at all the costs that are involved in terms of carbon footprint, as well as actual physical cost, and seeing what sustainability trends we can potentially promote and put forward. This will be done through educational policies and procedures, such as AGS magazine articles, such as the one that I wrote recently in relation to waste, pointing out with a good friend of mine that actually a WAC test is pointless and unsustainable unless you're actually going to send it to a landfill, because it doesn't categorize your waste. It doesn't allow categorization of hazardous properties, except in possibly one instance where it might suggest it. You cannot actually categorize it because European waste codes must be categorized on solids, not on leachable materials. So all your WAC will ever do for you is provide you with what landfill type of the three it might actually be appropriate to send it to. Therefore, by reducing WAC testing, because you know you're not going to send it to a landfill or anything like that earlier in the process, you are increasing the sustainability of it by making people aware that you should only ever be doing a WAC test if you're actually contemplating sending this stuff to a landfill. So we're doing all of that at the moment, conferences, online resources, which will include this chat with you tonight, and promoting general sustainability education and awareness for the industry, undertaking training and dissemination of that actual best practice that we're determining. There are also various AGS interactions between the subgroups because of the fact that this is now going AGS wide. We're also getting in touch with the geotechnical group and the labs group and the AGS data format group on ways that we can combine, not reinventing the wheel. So ironically, yeah, we're searching for a sustainable and much more effective way by actually getting people together to think about these things and put them together. So we're combining with the labs group on joint issues of concern. What is the most sustainable sample to take? How sustainable is QA/QC in terms of reducing the amount you totally need to take? Should we be trying to reduce the amount we actually send to the laboratory compared to the amount we actually sample? Making more efficient use of laboratories in analysis, basically. So the areas covered we've had at the moment are TPH, because if you don't choose the right one, then you can be completely stuffed. Also, you can find things with one type of TPH determination that you won't find with others. So, for example, if you're doing a TPH using a solvent to extract it, and that solvent is DCM, then you'll be missing anything that is actually wrapped around clay particulates. However, if you add another solvent to it, you can overcome that lipid barrier. And acetone is the one they normally use, and you will then get the total hydrocarbons, the real total hydrocarbons. But then again, there may be instances where you don't want that total hydrocarbons. If that material was to go to a landfill, for example, its chances of coming across solvents like DCM are not all that unlikely, but its chances of coming across something like a really harsh solvent like acetone are pretty much negligible. It's going to sit there around its clay, going nowhere, doing nothing until the cows come home. And so on that basis, if you are sending it to landfill, would you necessarily want the two-phase extraction to overcome that lipid barrier, to double the amount that's in your sample when you're sending it off for a waste? Probably not, because it's not justifiable. It's not sustainable. Containers. Should we be bunging everything in a plastic bag, or do we actually need to only take a glass one because we need to keep a sample in glass to make sure that it's not eating the plastic and therefore biasing the PAH and TPH results you're going to get out of it? Can we minimize the amount on the basis of the new techniques and sampling ways and analytical ways that we put out there at the moment, that we actually need to take as much sample in order to get it tested properly? Energy use, all of the different things in terms of getting transport from and to site, the energy use in actually undertaking the analysis, the GCMS, for example, or a plasma induction conduction spectrometer, you have vastly different amounts of energy and produce vastly different results for those reasons. So can we use more sustainable, more cost-effective, more energy-efficient methods for getting certain numbers out? Or is that just not possible? Looking at waste, that's waste produced by laboratories, because that's ultimately waste that's been created by the site investigation industry. How standards are applied, and particularly how MCerts should have an element of sustainability built into it, rather than just being a requirement for repeatability. So we're investigating the use of instruments and site monitoring as alternatives with the Monitoring and Instrument Group, which has been around for 2 years now. And at the moment, we're doing works with them on a joint article on the principles of sustainability, with further articles to follow. Basically explaining what sustainability is, how it can be hijacked, how it can be used to your advantage, and also why it's a good thing in and of itself. So we're looking also at combination with the data format group, because AGS sustainability on data transfer and its adoption as a British standard, and the promotion of BIMs, so that yes, in the future, when we come to knock down and rebuild this building, we don't have to do a site investigation all over again, because we've got all the data there, all stored, all associated with the building. Just need to look at it, say, yes, we still agree with that. Yes, tell us if you find anything unusual, get on with your development. Ultimately sustainable. With the geotechnical group, we're looking at site work specifically, and we're liaising with Equip and others on how we can actually undertake sustainability or promotion of sustainability for their clients, for the people who are drillers who are working for them or working in association with their procedures and protocols. So from here, we go through BSI, are continuing to ensure standards meet and consider suitable criteria. The Geological Society is interacting with the Contaminated Land Group and the AGS, promotion within the society as a whole, and there are going to be some quarterly engineering journal articles coming out, hopefully over this year, as part of the year-long process that's in place for journal creation. So keep your eye out for some of those if you get that magazine. We're also talking to Claire about sustainability and assessments, QP, validation, promotion of sustainability, and remediation as best practice, rather than necessarily dig and dump removal. The EIC Joint Industry Working Group, the AGS is already a member and is therefore through those forums going to be promoting this as well, to see what additional information or additional things other people in the group, like SoBRA, are undertaking and doing, so that we can present a united front. We're not reinventing the wheel for each of the different interest groups, and there is information that we can share, that we can gather, so we can do it in a most sustainable way by getting everybody else involved. In terms of Ciria, they're certainly looking out. I've had a word with Joanne about possible guidance and promotion of best practice, as has Paul Nathaniel as well, with his hat on for CIH as well as chair of EIC at the moment this year. So we're looking at quite a lot of things, getting them into train as to how we can do this. And for SoBRA, we've definitely got the heads up on a partnership in sustainability, because they have absolutely no desire to reinvent the wheel as well. So they're perfectly willing to come on board, steal from us, and at the same time assist us on the promotion, production of the information that we're going to be forwarding. The Environment Agency, as I say, works are ongoing, climate change and sustainability, because the two are not indistinguishable. The two are actually related, very, very profound way. So in the end, well, sustainability will never end. It will always be a goal we're trying to achieve. Now it's been realized that it's the only way you can achieve things. It will change over time, and it should do. It should change to reflect circumstances and the elements which go into producing it. So in some cases, environment may be considered more important, in others cost effectiveness, in others social aspects, in other elements reuse of land. Whatever your sustainability criteria you choose are, they're all ultimately parts of a sustainability that will never end, but the emphasis on them, the way that they're looked at, the way that they're considered, and the way that they're assigned a value should change over time, and will do. And that's exactly as it should be. Because you get different definitions from different angles, and one of those should be time. And standards should always be sustainable. They should be promoting that. They should be going that way forward. And hopefully all of those ones out there that we use at the moment are. Compliance with and use of standards should be ultimately sustainable, if only because the regulator will be expecting you to do it, and compliance with the regulatory requirements is ultimately sustainable because you're not going to have to do it again. Good practice, though, remember, is not always best practice. Standards will usually promote good practice because there'll usually be a series of options. It will usually say which one of those it thinks is the best, but because it suffers from a timescale of revision, it's not always the best practice. Somebody can write a report or do a study or something like that, and everything can change overnight as to what is most sustainable, what is most reasonable, what is the best way to actually do something. And that will change. So be aware that good practice is not necessarily always going to be best practice, be it standards or guidance. And remember the difference between standards and guidance. If it comes to law, basically, you'd have to explain why you deviated from a standard if a standard is applicable to that task and or has been required as part of regulatory compliance. So you need to say why that is. You can provide guidance as evidence as to, well, actually, this is not a standard, but it promotes good and or best practice in our industry. That's why we followed it. Therefore, you have a defense in law from guidance as well, but not to the extent you would have against an actual standard, unfortunately. Guidance standards, therefore, like the ones we follow, BS 10175, sort of fall halfway between the two. And therefore, if you're using it, you do need to be justifying A, that you're using it, and B, justifying where you're varying from what it would usually recommend. So it's vitally important that if you're doing this sort of thing, you actually know, understand, and have read it. Any help that you can give us in any of the above things that I've noted, please get in contact with myself or the AGS or this Contaminated Land Group of the Geological Society, SoBRA, or any of the other people I've mentioned, and please get involved, because the more people we get involved, the easier it's going to be to do this, the better it's going to be at the end of the day, and the more sustainable. So thank you very much indeed.